Yes, we welcome you back to PSSB, Physical Sciences Silver Bullet. It's Richard behind the channel. So let us look at this question. The question says that calcium carbonate can be decomposed by heat, as shown below. This is the reaction where we're having calcium carbonate decomposing to give you calcium oxide and carbon dioxide. And they say initially 2 grams of calcium carbonate is placed in a closed 500 cubic centimeter container and heated. Then the question says calculate the mass of unreacted calcium carbonate that remains in the container at equilibrium if Kc for the reaction is given. So this is a special case, that's why we picked it up. Okay, when you analyze what we have here, we are going to find out that calcium carbonate is a solid and calcium oxide is a solid. The only compound which is gaseous in this case is carbon dioxide. And what do we know about solids? Solids, during equilibrium, they literally remain unchanged. They do not change. The change is so small that it is insignificant. So most of the times we leave them out. So if you are going to leave them out, what do we say? So we are going to have our expression for Kc, and Kc is equal to concentration of product, which in this case is carbon dioxide, over concentration of the reactant, which we don't have because it's a solid. Remember, this one is out and this one is out by the virtue of them being solids. Okay, if you have this one, then what comes there? Then our Kc value is known, and it is 0.0108. So this one means that the concentration of carbon dioxide is that. Okay, if it's that, then what do? We can find the number of moles of carbon dioxide using the formula C is equal to N over V. Our C is 0.0108. We have it there. Our number of moles is needed, and the volume from here, the volume is 500 over 1000, giving you 0.5. So we have 0.5 cubic decimeter there. So from here, what are we going to? We're going to have our number of moles as. So we have now the number of moles of carbon dioxide. Those are the number of moles of carbon dioxide which was formed, because carbon dioxide is a product. So what do? Remember, we have to go back to the question and we say, what are we calculating? We are calculating the mass of calcium carbonate that remains in the container. So we come up with our equation. Is there? It's calcium carbonate decomposing into calcium oxide plus carbon dioxide. The reaction is balanced. We are going to start from moles. So this is what we are looking for. So it is earmarked, and this one is given. We know it now. So let us look at here. We have the number of moles here is 1 to 1. Okay. So if it's 1 to 1, now we know the number of moles of carbon dioxide formed, which is 0.0054. And because the ratio is 1:1, it's the same here, 0.0054. Okay, so these are the number of moles of what? Of calcium carbonate, which reacted, which decomposed. And what do we do with this one? It's convertible to mass. Using what formula? The formula is N is equal to M over molar mass. So when you throw up this one, what are you going to get? 0.0054 is equal to mass over molar mass of calcium carbonate. Okay, this one will give you N giving you will give you okay, 0.0054 is equal to M over 100. Calcium carbonate is known. So from here we get the mass. And what the mass? The mass is 0.54 grams. Okay, but now we have to know, what is this mass? This is the mass of calcium carbonate which decomposed to give you carbon dioxide and water. And the question is looking for the mass which remained in the container. So what do we do under this circumstance? You say mass excess or mass unreacted is going to be mass added minus mass reacted. So in this case, what was added? It was 2. What was reacted? It's 0.54. So what's the mass in excess, which you have in the container, is the difference there. Okay, so that is that. The mass of calcium carbonate which remained unreacted in the container is 1.46. Okay, we thank you for your time. We thank you for subscribing. If you have not, please do so. We believe and we promise that you'll not regret. See you next time. Bye bye. The channel is PSSB, Physical Sciences Celebrate, and it's Richard here. Okay, people.